Okay, I haven't thought about how we want to do this. I can either go through the questions that are highlighted, or if you got specific questions that you want me to ask, you want to talk about, we can do that as well. Right. So this session be useful if you're willing to talk more. So okay, so let's do it this way. I go from top. If let's say you want me to go through the question, I go through. No, I'll just skip past it. Okay. Let me just clear the screen a bit. All right. So question 4 and 5. Shall we talk about 4 and 5? Let me open the chat so that if you're lazy to mic on, you can chat. Yeah. Should I look at 4 and 5? 4 can. All right. Okay, so 4 is quite okay. I purposely chose these two questions because they are not so intuitive to do lah. All right. So, but I think it's good to recap them. Okay, so let's just look at question 4. Question 4, you have a 3 kg block that is on the smooth surface at a speed of 2 meters per second. Constant force is 1.5 Newton exerted on the block over 2 seconds in the fixed direction. Okay, so there are a few concepts happening here. Let's just draw over here lah. Right, so I have a block. Okay, this block, right, we do not know the direction. Okay, so let's just assume that it is moving to the right hand side. It does not matter. 3 kg, 2 meters per second. So 3 kg, and 2.0 meters per second. All right, so from here, right, you probably can see that, oh, then you have a force that's acting for a period of time, right? So there are some concepts involved here. First, you talk about momentum, right? Momentum is P equals to mv lah. So in this case, this is initial momentum, right? I can work out my initial momentum in this case. So Pi is equals to mu. This will give me 3 times 2. I get 6 kg meter per second. All right. So this is what I have for initial momentum. Right. So I hope you remember how you're going to change momentum. You know, change momentum, right? It's always about force, right? So if we go from this equation here, if we go by Newton's second law, I can say, oh, F equals to delta P over delta T. So from here, I say, oh, actually my delta P, right? Change in momentum is just force times delta T. Okay. So over here, I have a change in I have a force acting for a period of time. So it's a 1.5 Newton force for 2 seconds over here. All right. So I can find the change in momentum, right? So in this case, will be 1.5, 2.0. Okay, I get 3.0. This one, the unit is Newton per second, which is actually you can check the unit is the same as 3.0 kg meter per second. Okay, same as this one. Okay, so the difficulty in this question is that right now, right, you can see that the direction of the force is not defined yet lah. Okay, so the force, right, this extra 1.5 Newton force, right, how is it deployed with regard to your block? Okay, is it, say for example, you can be this way, okay, it can be this way, it can be this way. We have no idea yet. All right, so there is a range of answers that are possible as well. All right, but if we want to change the momentum, the original momentum, right, as in we don't want, okay, of course you can apply this way, but the question is asking you for the, which cannot be the magnitude of its final speed. Okay, so I'm looking for what's the maximum. Okay, when I add this extra momentum in, right, what is the biggest sum I can get? What's the biggest difference I can get? All right, so if I want to increase the momentum, right, I will give it in this direction. So let's say let's try a force out. On some changes. Give me a minute. Okay, so I can either put my force here. So let's say this force can be this direction, okay, or it can be something on this side. All right. Okay, so between these two directions, right, anything in the middle here. Okay, so if I want to have maximum momentum, right, I just put the force in this direction. Okay, if I put it in, let's say for example, let's say I give it in this direction here. Let's say I put in this direction here, right, like that, right. Then I'm only taking the horizontal component here. So if I do the blue color arrow direction, right, I will not maximize the change in momentum. Okay, I'm only using a component of it, not the full length. So if I want to get the full length, right, I will place it parallel to your original velocity. Okay, same thing. If I place it this way, this will not change my horizontal speed, right? Because this is right now vertical. It's not in the direction of the original momentum. Okay, then this one will give you the smallest momentum, because this guy will directly cancel off the original, will reduce some of the momentum here. Okay, so this will give us the smallest answer. All right, so we need to work out what are the possible scenarios that can happen. All right, so let's say let's call this A and B lah. Okay, let's call this A, and then this is B. Okay, so that's for FA. Let's say we do for A, right? Okay, for A, right, my change in momentum is in the same direction as the force, as the original momentum. So I'll do my final momentum is equals to P initial plus delta P due to A. Okay, so this will be 6 plus 3. I get 9. Okay, then if I do for B, okay, it will be PF equals to PI plus delta P delta B, delta PB. So it's 6 plus negative 3 now. Check values. Negative 3. Okay, so this is 3. Okay, so note that this is the momentum, right? So I need to go and divide by the mass to go and find out what is the velocity, right? So I go on. If I do find the final velocity, this will be 9 over 3 kg. Okay, so this one I get 3.0 meters per second. This one I do the same. The V will become 3 over 3, so 1.0 meters per second. Okay, so this means that if I give it a rightward force, let's say this one here, my final speed will become 3.0. If I give it a leftward force, my final speed become 1.0. So these are the two extreme range already. You cannot go less than that. You cannot go more than that. Okay, so because if you go, let's say for example, you go somewhere in the middle here like this, right? Then your change in momentum is only this portion. Then it's smaller. Okay, let's say you go something like this direction, right? You only want this component as a result. Okay, so again, it's not as big as this guy here, right? So we need answer between 1 and 3. So in this case, the best answer would be, okay, so 1, 2, and 3 are both possible. So only one that's not possible is A. All right. So this one is a bit interesting. All right, questions? Pause, you can type. I'm okay. No questions, huh? Can. Okay, let's look at 5. I'm just going to squeeze it here, right? Okay, 5, right? So this one looks like a very straightforward question now. 5 kg block, rough slope, incline angle 30 degrees, string attached. Then go and find acceleration, right? They give you tension and frictional force. Okay, so let's join the forces first. Standard, start with free body diagram for this guy. So you have the weight here. Okay, this is the weight. And then you have, of course, you have tension here. Okay, this is tension. Tension is how much? 2.0. Okay, weight is 5 times 9.81. 1. All right. Okay, so now the problem is the frictional force, right, is which direction? Okay, the way I see it, the frictional force is not very obvious, because here, right, okay, remember it depends on how your block is going to accelerate in the first place, right? If your block is going to accelerate upwards, right? If your block is going to go upwards, right? That means the net force of these two guys are upwards, right? Then your friction will be down. Okay? If these two forces causes your block to accelerate downwards, right? Then the friction will be upwards. Okay, so it's not so obvious at the start lah. But if you look carefully, right, then you can look for clues to tell you, actually, right, the block will accelerate downwards at this point of time. Okay, because right, what we can do is that, okay, we can work out the parallel component of the weight first. Okay, so let's join the components, right? So this is weight perpendicular. This is weight parallel. Okay, I want the weight parallel because I know that my block, right, will move along this direction. Okay, so I'm not going to use this vertical component, this vertical direction weight. I will not use weight perpendicular because this is not in the direction of my velocity ma. And this guy will be cancelled off by the normal reaction force. So I'll just use weight parallel. So weight parallel here, because the angle here is 30, right? This guy is 30. So I can find weight parallels. So weight parallel is equals to 5.0 times 9.81 times sine 30. Okay, do I have a calculator for one? I do have one. So this is 5. Yeah. 5 times 9.81 times sine 30. Okay, so I get 24.5. Okay, so 24.5, right? That means this force here, let's write it down. Sorry. This force here, right, is equal to 24.5 newtons. Okay, so now if we consider these two forces, the tension 2.2 newtons upwards, right? And then 24.5 newton downwards, right? The net force is down the slope. Okay, so in this case, right, your friction has to be acting up the slope. Your friction is in this direction. Hold on, let me draw it nicely. Red color. Like that. Okay, friction has to be this direction. Okay, so if you want to write some comments, right? Okay, what you can do is that, okay, so we can write because W parallel is larger than tension. Okay, F net is downslope. F net, so A is also downslope. Okay, so hence my friction X upslope. Okay, so once I've established that, then you can go and find. So then you go and find F net lah. Okay, so F net now, because friction and tension working together, right? So this is T plus F minus away W parallel. Okay, so we can sub in now. Okay, so we realize actually downslope is larger lah. You realize that this calculation here, right, will result in a negative value lah. Okay, but not important. So this will be 2.0 plus 3.0 plus minus 24.5. Okay, plus negative 24.5 lah. Okay, I think let's just go right as minus 3. Okay, let's write minus 3. 24.5. Okay. Then from here you'll get how much you get? You get negative 19.5 newtons. Okay. That means this is pointing down slope. Okay. Then you find acceleration. So acceleration will be F net over mass. So this will be 19.5 divided by what's the mass? 5 kg. 5 kg. 5.0. Okay. So go from there. So this will be 4.9. 4.9. Oh, 3.9. Yeah, because it's 20. 3.9 meters per second square. Can. Okay, so this one, the interesting thing is you need to spend some time to go and work out what is this frictional force direction. Okay, it can be up or down also. Can. Anything for this one? Okay, moving on. 6, is it okay? Do I need to go through 6 for you guys? I can't do most of the J2 questions. Okay. The JC2 questions lah. Okay, that JC2 means the second JC, not JC, not JC1, JC2, right? So 6, okay, I skip. Tobias, okay, I skip 6. Okay, skip 6. Move on. 7 should be okay as well. 7, basically three forces there. They will not cancel to give you 0. So we need to find out what is the resultant force, then apply the fourth force in the opposite direction. Okay. So I think this one, I think actually if you can kind of rule out some answers straight away. You can rule out option A and D A and C quite quickly. Because A and C, right, they are both measured from line P, right? Even line P is here. You can rule out those that are pointing upwards. So 9 and 68 you can rule out straight already. 248. 248 is actually pointing 2480. Yeah. This is 90, 70, 91, 80, and 240. Yeah, so it's a bit hard to rule out these two guys, but you can rule out A and C quite fast. Right? Okay. 8. All right. Question 4. So these are the second JC's questions. Yeah. Second JC, I think is I want to say it's EJ, but I can't remember which one I picked. Yeah. One of it is from NYJC. NYJC is some of the questions. Yeah. So what I did was that I go and open the two JC's papers from paper 1 to paper 3, right? Then I just extracted all the questions according to the 5 areas that I want to talk about. All right. So tractor mass 1000 kg, pulls a trailer of mass 1000 kg via tow bar. Total resistance to motion has a constant value of 4000 newtons. 1/5 of this resistance acts on the trailer. So 1/5. All right. If the maximum pulling force or braking force of the tow bar is 3000 newtons, right? What's the maximum acceleration? Okay. This one, the tractor is not important because everything depends on tow bar. Okay. So let's draw the diagram first. So we draw the tractor and then the tow bar. So tractor and trailer. So this is the tractor. Must spell in full because tractor, trailer. Okay, so both of them has mass of 1000 kg. 1000 kg. Okay. Then they tell you that um total resistance to motion is a constant value of 4000. 1/5 x the trailer. So let's say I'm pulling, in this case I'm pulling this direction, right? So that means my tractor here will have a resistive force of how much? 4000 times 4/5. So this is 3200 newtons. And then this guy has a resistance of 800 newtons. All right. Okay. Then they tell you that the maximum tow bar force, right, is 3000 newtons. So that already tells you that this force here, right, this tension here, this is 3000. Okay. There's no need to involve the tractor anymore because right now, right, our free body becomes only the trailer. Okay. So all you need to do, what are the forces acting the trailer? Just the resistive force of 800 newtons, and then the tow bar tension 3000 newtons, right? Then you can find F net. So remember your F net is equals to uh 3000 minus away 800. 800, not 8000. Okay, so this 2200 newtons. Okay, then find acceleration. Acceleration is just F net over M. So 2200 over 1000. So we have 2.2 meters per second square. Okay, it's a bit of a trick question. The tractor not important. Okay, tractor just for show. Yeah. Okay, it's question 4. Question 5 and 6. Anything for 5 and 6? You all try 5 and 6. Anything for this page? 5 and 6. 5. All right. Okay, 5. Okay, let's look at 5. 5. Cylinder radius are made of materials A and B placed on a rough floor as shown. Portion made of material B has a radius of 0.45 r. So the center portion. Center portion here, okay? 0.45 r. And the density of rho that's half that of material A. O is the center of cylinder. And P is the center of material made in. Wow, what's so complex one? Aiyo. I haven't tried this question yet, so we wing it and see how. If the material is made entirely of A, its weight is 90 newtons. Force is applied at F. Wow. Oh, how to do this? O and P same height. O is the center. 19 newtons. Oh, then the CG is shifted. 0.45 R. What's the force that's required to? Hmm. I don't know. I learned something in uni about this, but I don't know how is it applicable. Ah, okay. Pivot is here. Okay, let's find out. Let's fill in as much stuff as we can. Pivot is here. So there is one moment here. There's one force here. So this is force on P. Ah, wow. Okay. I want to check what's the answer first. Hold on. As in, I want to do and find answer first. Okay, I'm going to try. Oh, I don't know how to start this one, sir. If I take this momentum, if I find this moment due to this center, the center one here, right? Okay, let's see. 0.45 R. Wow, this is a lot of steps, I realize. A3. Okay, so I find the weight of material B. Okay, so this one, the moment torque due to B is equals to weight of B multiplied by R3. Okay, so weight of B is just treat it like a cylinder radius R made by material. Okay, so there's a depth term now, which is not important. It's just a D term there. Okay. While Luke just left you, I just realized. Huh. Wow. Why you pick such a hard question now? So for third pi 0.45 R. No, not speed what I'm doing. So it's just pi 0.45 R square times the D, okay, times volume times D times this is the volume times density of B, 10 times R3. Okay. If this is supporting, that means this one will want to rotate this way downward. So this is look, I will hold this to the end first, can? We hold it to the end first. If not later this video will have a lot of pause time in the middle. Okay. You got any other questions from this one? So what 7. Okay. So 7 I just go like the whole thing, huh? Okay, 7, 7, two blocks P and Q masses 0.5 and 1 kg respectively connected by a string that pulls over. Spring constant is 200 Newton per meter. So Q obviously heavier, Q will come downwards lah. Okay. So determine the tension of the string just before block Q strikes the spring. So that means first part I just talking about the case where what is the when you release it, right? What was the tension? Okay. So we can do the free body. This kind of question is good to just do the free body diagram for both of them. So for P, right? For P, it will be you have weight of P, then you have tension. Okay. So then for Q, okay, let's do for P first. That's right here. So for P, right, your F net is equals to MA, right? So that's what I like to write. Okay, let's start with the values. So this is so in this case, tension will be larger than weight of P, right? So no issue. So tension minus weight of P, which is tension minus weight of P is equals to MP times A. Okay, so do we know the values for mass? Okay, so T minus 0.5 G equals to 0.5 A. Okay, so then we're going to make A the subject because later we are supposed to find T. All right, so we're going to make A the subject. So just nice. So this is 0.5 A equals to T minus 0.5 G. All right, so this is equation 1. Okay, next one, you have Q. Q, you have weight of Q, and then you have the same tension. All right, so for this, I'm going to use another color. So same thing, F net minus F net is equals to MA again. So this will WQ minus T. Now I use WQ as positive because this guy will go downwards. Equals to MQA. Okay, so sub in. So this is 1 kg, right? So 1 G lah. So G minus T equals to A. Okay, because it's just 1.0, 1.0. Okay, so A is equals to G minus T. Okay, then this is equation 2. So once you have that, equation 1 equals to equation 2, you have T minus 0.5 G equals to G minus T. Okay, so you have 2T equals to 1.5 G. So T is equals to 0.75 G. Okay, so first one, okay. Okay, next one. Okay, next one, see what's happened. Okay, compression of spring. So block B, okay, block Q decreases acceleration after it touches the spring. Block Q comes to a permanent stop. So this is VQ equals to 0, which means VP is also equals 0. So kinetic energy becomes 0 for both of them. Okay, calculate compression of the spring X. Okay, for this we need to know do we know initial height? You never give me initial height, from rest. Press A. Calculate the compression of the spring. Okay, so they never give us height. So this is actually quite interesting. We see what we can do. All right. Okay, so okay, if there's no spring, the final velocity of two of them, right, is from this. Okay, so let's write the equation first. So if we find change in KE of P plus change in KE of Q. Okay, these two here, right? Basically, the initial KE is 0. So that means this is just equals to KE P final KE of P plus KE final of Q. Okay, and this comes from two things. Q because Q will come downwards, right? Q will lose height. So Q will lose GP. P will gain GPE. Right? So then we can write here. So this will be delta GPE. This should be positive, right? Yeah, I had to write this way because it's very hard to write it like that. Okay, plus delta GPE of P. Okay, so this one I will write as MQGH. I should write as positive. Then this one will be MPGH. Okay, minus. All right. So this one is very interesting. So the velocity will be the same lah. So half MP plus MQ B square equals to MGPH. Okay. Okay, so continue first, then we see what all you get from here. So let's start with numbers. So this is half 1.5 B square equals to 1 minus 5. So 0.5 GH. Okay. And then I want to, okay, so this is the KE that you will have. This is the GPE that it will be lost. And this is equals to half KX squared of the spring if everything is lost. Do I have enough information to solve? I don't know height though. Did I miss out information? Okay, I go look at answer key. The ZA, sorry. Question 7. 3.2. Okay, even my first answer is wrong. Yeah. Oh, use forces. Who's coming in now? What Tobias are coming in? Use forces to solve. Complete stop. 6.54. Wait, why am I first answer wrong? GG. T minus WP. So this one's a cancellation problem. 6.54 newtons. 0.75 Gs, right? Okay, okay. Oh, so just use complete stop. Okay, okay, I get it, I get it. I go and think in terms, okay, the mistake was to think in terms of work done lah. Okay, let me remove all this stuff. Now this is not necessary really. We draw the final diagram, that makes sense. Okay, final diagram is like this. So for P, right? For P, when it comes to a stop, right, it will just be weight of P and then tension. So this one, right, because now Q has come to a stop on the block, right? So P will not accelerate as well. So AP is equals to T. This two are equal to each other lah. Okay, because your acceleration is 0. So T minus WP over M equals to 0. So T is equals to WP. Okay, so that's fine. Then on the other side there, right? On the other side, you have three forces. You have weight of Q, you have the tension, you have the spring force. Okay, that's why it's Fs. Okay, then now it's clear, right? Okay, so again, this block acceleration is 0. Okay, so I can say Fs plus T minus WQ equals to 0. Why is that? Oh, because the block come to a complete stop. So this is up after this guy, you release, right? This will move up, this will come down, right? So come down. Once it comes to a complete stop, right? Then your setup looks like this. I draw the setup again now. The setup look like this. So the spring was here. The spring is now being compressed. The block is here, Q. Then up. Then this is your pulley. Your P is here. Like that. So Q is no longer accelerating. Okay? Okay. Okay. So now this one should be okay, yeah. Should be doable already. So tension here, right, is just equals to weight of P lor. So Fs plus, okay, let's write one more line first. So because T is equals to WP, I can write Fs plus WP minus WQ equals to 0. So Fs equals to WQ minus WP. So this is 1.0 minus 0.5, 9.81. Okay, so 4 point something lah. 4.9 newtons. 4.9 newtons. Oh, I was supposed to find extension, right? Sorry. Compression, right? So from there, then you go and F equals to Kx. Okay. So from this one, then you go and do F equals Kx. So because K is 200 newtons. Okay. So K, then find X, X equals to F over K. So 4.9 over 200. 200, not 2000. Okay. Yeah. Next one. B near. You need 7B? Mm. Okay. So bullet of mass 5 kg fired from a gun into a block of mass 0.5 kg. Suspended by thin thread from fixed points, bullet remains in the block. Okay, swings out. So remains a block here. This one here tells you that this is an inelastic collision. Okay, so that means KE not conserved. Okay, stuck together means K not conserved. Yeah, so have to be careful if you are doing it that way. Okay, determine the maximum height H. All right, so for this, you need to find part one, need to go from total momentum first. Find the initial velocity of the block after the bullet is stuck into it. All right. So for this one, momentum. So okay, so let's capital M and small m. So okay, let's write. So this is 5.0. Okay, yeah, I should write in terms of kg, right? Okay, so conservation of momentum. This one will tell me that 0.005 times velocity 100 is equals to the final momentum, which is total mass will be 0.505 mass of bullet and the block times V. Okay, so find V first. Okay, so V here. Okay, how to find V one? I'm gonna put my calculator alongside. Can I do that? How do I do this? Okay, scrolling down a bit. And another window. Calculator. Okay, like that. Yeah, let's zoom in a bit first. Yeah. Okay, so let's try. Point 0.0005 times 100 divided by 0.505. So this is 0.990 meters per second. Okay. Then find maximum height, right? So this one, then this is just now this block and bullet has KE, right? So KE will cause it to swing up and gain height. Gain height, you will gain GPE. So that means change in GPE is equals to change in KE lah. So this one, so you can do mg, okay, the combined m so m total lah. Mg delta h is equals to half m total u square minus v square. Okay, so this one you can cancel the mass. The mass will go off. So this is 9.81 times h here. So half u square is 0.990 square minus 0 square. Okay, then solve for h law. Okay. So this will be square divided by 2 divided by 9.81. 0.049. I don't know whether it's right. Right? Let's maximize this guy. 0.049. Yeah, the height. Okay. Look okay.
Can I ask that why can we use
Sorry. You hold on, I can't hear you. I up my volume first. Yeah, you're saying?
why can we use the conservation of energy when
You
there
cannot
are
use conservation of energy. Oh, for which part?
the second part, the change in GPE equals change in KP?
Why not conservation of energy?
Because I thought that they are inelastic, so like any form of
Oh no, the inelastic part happens above here. So there are two things that are happening here. One is when the bullet first goes into the block. So that portion, then the bullet gets stuck in the block, right? This portion is the inelastic collision part. So here, so there's a line that I draw here. So this portion is the inelastic collision. So after you find that velocity, right? That 0.990, right? That means this okay, you draw it this way. So let's say your bullet comes in with V equals to 100, right? The block is here. Okay. So this V is 0. Okay. After it, it becomes like that. The whole thing gets stuck inside. Like that. Then this guy now has a velocity of 0.990 meters per second. Okay. Then after that, you will swing upwards. So you go up to the higher height lor.
okay.
The third stage is okay, so the third stage, this is the initial one. Then it goes to here. Is 0. As a height h, delta h is more than 0 lah. Can? Okay, so this
So
is B. Sorry?
it's only the collision part I can't use the energy.
Yeah, correct. Because that one is inelastic collision. Mm. Yeah. S7. Yeah. Need 7C or not? Take mental break first. You tell me you need 7C or not.
We actually need the,
Sorry?
the part two, C part.
7C part 2 is it? So that train will not travel beyond the open part of the track one lah. What is it? This one Okay. This one, let's see Is there any conservation energy for 5 meters? Negotiate 23-meter diameter loop before ascending the 4.5-meter track. Falls backwards under its weight. Going through the loop a second time, ascending the back vertical track. Okay, so this vehicle goes like that. The vehicle goes from here, goes like this, up, come to here, then roll back down, one full round, then go back up, and come back to here. Right? A bit complex, but then, yeah. Okay, let's do the whole thing lah. Okay. Determine the average power required by the mechanism to bring the train to 89 km per hour in 4.5 seconds. So this one just find change in KE lor. 28 riders in a single train 7 cars combined mass. Train got any mass or not? Don't have So this will be work done. Okay, power is equals to work done over time. Change in KE over time. So this will be half 6,589 divided by 3.6 square divided by 4.5 seconds. Should be correct. So let's just try 89 divided by 3.6 square times 6,500 divided by 2 divided by 4.5. 44141. You check answer for me is correct. Yeah, scroll down. 441413. Yeah, okay, so this is fine. Okay. Okay, so let's look at the rest of the question. Show that the train will not travel beyond the open part of the track after emerging from the loop. What's the open part of the track? Find change in loss in gain in GP must be equals to gain in KE lah. Yeah, so if you want to gain GP, you have to lose KE. So in order for you to gain this height of 45 meters, right, you must gain 45 meters worth of GP. Okay, so you can work out how much energy the train has right now lah. Okay, so if you go and find, okay, so that means you can see, okay, delta GPE is equals to delta KE. So this is mg delta H equals to half m delta V whole thing square. Okay, we sub in lah. So we can cancel off m's. We don't need the m's. So this is 9.81 delta H. Okay, let's put delta H there first. Okay, then you're going to do half V square lah. Half 89 over 3.6 square. Okay, then check what's the delta H. So this is 89 divided by 3.6 whole thing square. Then divide by 2 divide by 9.81. You get 31 meters. 31.2 meters, which is less than the 45 meters there. So the train will only travel up to the 31 meter mark. You won't go all the way to 45. Okay. So this is part 2. Part 3. Each rider is restrained by a lap bar. Should the lap bar's mechanism fall and unlock itself as the train negotiates the loop? Determine if the rider will fall off the train. 3 marks are save my trouble. 89. Can I just go convert the 89 to speed? Okay, this one, okay, so we want to basically, right, you need to work out at the top of the at the top of the circle, right? There, right? Here, over here, right? You're gonna have velocity, right? So remember here you will have weight, you will have normal reaction force. There's normal reaction force from here, like that, normal reaction force. Okay, then you have centripetal. You're trying to find these two forces will give you a centripetal force. Okay, remember as long as your normal force is non-zero, that means you still have contact with the seat. The seat is still in touch with you. Okay, so we need to check whether this n is it larger, is it more than 0 or not. Okay, so for this velocity here, right, because your entry velocity is not the same. This is another velocity. This is equals to 89 km per hour lah. But because I gain height. If I gain height, right, I need to make sure that I find the loss in GP as well. Okay, so fun. Okay, let's try. So we're going to find speed. Okay, find speed at top of loop. Okay, so find speed there. Okay, so how to do is we have delta GPE equals to delta KE lor. Okay. There's a formula lah, but I don't really remember the formula. The something 5/2g one. That one, I don't bother. It's just faster to do quickly lah. As in, so this is mg h is height is 23 meters according to the question. So this is 23. This is 23, right? The circle is 23 meters. 23 meters in diameter. So later when we do the mv square r, we have to be careful. We cannot use 23. So this is half mv square. Okay, I'm not, because later I know that I'm going to use mv square, right? I will keep the mv square. Okay, so I'm just going to shift things around. Okay. Oh, because this is weird. This is, oh, cannot yet. So much fun. Okay, so go and find this v here will be, this is v u square minus v square. Okay, so go and find out what is, I will take out mv square. Okay, so half mv square. So damn it. So m half mv square is equals to mg 23. Wait, what am I doing? Half mu square minus mg 23. Okay, then go and find mv square for me. Okay, once I found mv square, right? Then leave it as that first. Okay, then we look out net force. So centripetal force in this case, right, is provided by your normal force and weight, right? So centripetal force will give me centripetal acceleration, MAC lah. So this N minus W is equals to M V square over R. Okay, so that's why I purposely don't want to disturb this half MV square term, because MV square term is here. Okay, then go and divide R, but R here is need to divide by 2, so 11.5. Okay, then you just check whether N is larger than 0 or less than 0. If less than 0, that means you will lose contact. Should be okay, right?
FC equals N minus W. Is that at the bottom or is it at the top?
Oh yeah, N plus W, sorry. N plus W at the top. Because now your normal force is working together with your weight. Okay, ma?
Yeah, that's all
Yeah.
for N.
Okay. D. This is a paper 3 question, I think. So long. D, yes, this. I owe you the long question, right? This one, honestly, I'm quite stuck with this one. Okay, I'm going to take this offline since I will out on my own now. This video will have a lot of wait time. Okay? You have any other questions from this set?
No questions.
Don't have. Okay, so once I figure out this question, I will send to you. Okay? And Tobias, bye.
Thank you, Mr. Kong.
Bye, Luke. Bye.